Welcome to PowerPoint number 2 about percents. We're going to be focusing on using benchmarks and highlighting some of the strategies that Beckman provides to think about how to solve percent problems. Beckman focuses a lot on using math drawings, and in her math drawings of percentages, she's using area models. Some of the strategies can help us make sense of percentages. Study the drawings and notice that several different benchmark percents are shown using different shaped figures. Percent is shown as part of a total area. The circle is divided into 4 equal parts and 25% is shaded. This is equivalent to the fraction 1/4. The rectangle is divided into 2 equal parts and 50% is shaded. This is equivalent to the fraction 1/2. The square is divided into 4 equal parts and 75% is shaded. This is equivalent to 3/4. The long rectangle is divided into 10 equal parts and 10% is shaded. This is equivalent to the fraction 1/10. The vertical rectangle is divided into 5 equal parts and 20% is shaded. This is equivalent to 1/5. The final rectangle is divided into 20 equal parts and 5% is shaded. This is equivalent to 1/20 of the circle. So you see how the percentages play out and how we mark them and color in a certain shaded area. Just in case you were wondering, here's some explanations that go with each one of them so that you can see what was going on. Notice that the person divided the rectangle into 5 parts. 4 of them are in 20% parts, and the last one is 15% because one small 5% part has been removed. In problem 2, the person has divided the rectangle into 4 equal parts of 25%. 3 of them are fully shaded, and the last one, only 5% of the 25% is shaded, so that's a total of 80%. In the next one, even though they haven't put in all the lines, what they actually have done is divided the rectangle into 10 equal parts, and 4 of the 10% parts are shaded fully, and then half of one of the 10% parts is shaded for another 5%, so the total of 45% is shaded in the figure. In this next problem, the rectangle is divided into 4 equal parts, and one of the parts has been cut in half, so we're taking 1/2 of 25% is shaded, or 12.5%. In the last one, we have 2 equal parts, 50%, and then 3/4 of 50% is shaded, so we have 87.5%. You may have reasoned differently, that's okay, but could you make sense of them? That's the big question. The drawings are the start for thinking about our percent problems. Finally, Beckman does talk about the symbolic representation, and you see 3 different kinds of ways of stating this in her section 2.5 in the chapter. She states it first of all as P% equals portion divided by the whole amount. Or in another location, she changes it to P over 100. Remember that a percent is out of 100, so it's P out of 100 equals the portion divided by the whole amount. And then she goes further and shows us that the P% is related to the portion that we're looking at, and the 100% is related to the whole amount. So those are her symbolic representations. We will pick up with the first one. P% equals portion divided by whole amount. So we see this here, and then on table 2.1 in her chapter section, she actually deals with benchmark percentages expressed as fractions. So she says that 25% equals 25 out of 100, that's the portion of 25 out of 100 is the whole amount, equals 1/4. And then another benchmark percent is 50%. That's 50 out of 100, or 1/2 as a fraction. Then 75% equals 75 out of 100, which is 3/4. 10% is 10 out of 100, equals 1/10. 20% is 20 out of 100, and if we make that in lowest terms, it's 1/5. And 5% is 5 out of 100, or as a fraction, 1/20. So these are benchmark percentages that can be very helpful to us when we're making drawings. So we're going to use math drawings and percent tables and make some calculations. So in the first example, the problem is to calculate 95% of 80,000 by calculating 1/10 of 80,000 and then calculating half of that result. Use the following math drawing and percent table to help you explain why your method makes sense and to record your thinking. Is there more than one way to find 95%? So you start off with a blank rectangle, and in this case, the student did this. The student divided the rectangle into 10 equal sections, and then he calculated 1/10 of 80,000 and marked it off. And actually, since there are the 10 equal sections in 9 of the sections, he marked off the 80,000. And the last section is half of one of the 1/10 sections, or $4,000 that we're looking at. Now this is the benchmark piece, so we have 10% is 8,000, 10% of 80,000 is 8,000, and then 1/2 of the 8,000 is 4,000. We can use this to set up a more abstract model called a percent table. When we're learning to make and reason from math drawings, we need a more formal way to record our thinking. We use a percent table. Notice that the left side has been filled in for you strategically using benchmark percentages. And these are actually the percentages that the student used. We are given 100% is 80,000. So we start off with the given. 180% equals 80,000. And then the student went ahead and figured out 10% of 80,000. So we show the calculation, 1/10 of 80,000 equals 8,000. And then we read about how he calculated half of that result. So we show the calculation, 1/2 of 8,000 equals 4,000. And then in order to get 95,000, we have to combine what we know above to make 95%. So in this case, 80,000 minus the 4,000 of that one white subsquare, and we see that it's 76,000. Finally, we can do the symbolic form that maps to this as well. Notice that 95% equals a portion, 76,000, divided by the whole amount, 80,000. So the drawing got done first. It suggested benchmark percents we might use. The percent table you create, in this case we've been giving you some hints about what that table might look like, and then you show the computations that let you figure out what the final answer is. Here's another problem. A restaurant server receives a $7 tip on a meal he served. If his tip represents 20% of the cost of the meal, then how much did the meal cost? Solve this problem with the aid of a math drawing and a percent table. So here you are with a plain rectangle, and you've got to section it off into 20% parts in order to figure out what you're going to have for a total cost. And remember that the tip is one of these. It's $7, and it's one of the 20 parts. So it means the remaining 20% parts will also be $7. Here's a drawing that a student did. 20% equals 1/5, and he showed the $7 each of the 5 times. So we've got a drawing that basically solves the problem for us, but we've got to go to a percent table because that's our more formal way of representing a solution to the problem. So then we go to our percent table and we include the benchmark. So 20% is the same as $7. And then we want to know the total cost of the whole meal. So there are 5 sections, each with $7 in it. So the total cost of the whole meal is $35. And if we go one step further, we can see with our final symbolic representation that we have a $7 tip out of a $35 meal equals our percent of 20%. So when you're working with percent problems, Beckman suggests, and I strongly suggest as well, you want to make a math drawing first. The more the math drawing helps you figure out the answer, the easier it will be to then translate the information in that math drawing to make a percent table. Use the math drawing to guide your work if needed. And then finally you can connect back to the symbolic form expressing percent relationship.